Alright, in this episode we are going to be exploring increasing and decreasing functions, properties of increasing and properties of decreasing. So I drew a function here, the graph of a function. Let's just call this y equals f of x. So this is f of x in green, and I've labeled certain points in magenta and labeled them in orange. So at point A, this would technically be x1, comma, f of x1, and so on for each other point at point B, point C, and point D. I think I'm just going to easily refer to this by the labeled points that I gave them, so I won't confuse you too much. Alright, so it's kind of easy to see where the function is increasing from and to where it's decreasing from. Obviously, it's between point A and B. The function is increasing. We're going, as we go along the x-axis to the right from 0, we have a positive slope. We're going up. And then when we hit B, by the way, B and C are called turning points. They are when the graph switches from increasing to decreasing, and it is at these points that it is neither increasing nor decreasing. This is a maximum. Point B is a maximum, and point B is C is a minimum. So it's increasing from A to B, and then from B to C our slope turns negative at the turning point B. So now it's decreasing, and then at C, when it gets to C and passes C, and the slope turns positive, and now we go up the graph to point D, increasing, decreasing, increasing. Now, how do we write that as like a rule, or how do we concretely define increasing and decreasing? Well, there's a way to define it. And a function f, let's just call it, is increasing on an interval and we'll call it I, if, and then f of x1 is less than f of x2. Whenever x1 is less than x2 in I. Okay, so that's easy. So if x1 is less than x2, f of x1, if f of x1, which would be right here, is less than f of x2, which would be right here, and it is, then the function is increasing between these 2 points. Alright, so that's not too hard of a definition, and I am pulling this definition straight out of the book if you're following along. The function is decreasing when? In the opposite case, right? So it's decreasing on I if if f of x1 is greater than f of x2. So let's look at this. If f of x, let's say this is f of x1 now, and let's say this is now f of x2, just for this example, not in reality because it's not according to this graph, but let's say this is now our x1 and this is x2. If x1 is larger than or greater than x2, which it is for this made-up case, then between these 2 points the graph is decreasing because you're going from a higher point to a lower point. From here you're going from a lower point to a higher point. So this is a pretty easy definition of increasing and decreasing functions. And in the next video I'm going to show you an example. Maybe we'll do some examples of increasing and decreasing. Actually, in the next few videos I'm going to be doing some homework problems straight out of the book from section 1.1 in the Stewart's calculus. So if you're following along and you want answers to that, you will want to watch these videos. Increasing and decreasing, by the way, are important in calculus. This is why this section has it, because actually you will see this again in future chapters and whatnot. So get it in your brain now really well what increasing, decreasing, and increasing is. Okay? See you in a future video.